In this session, I'm going to show you various tips about high-performance Java persistence, and I think those are going to be very useful because you can readily apply it in your project. So it's going to be very practical for your daily use case. Okay, now a little bit about myself. My name is Vlad Mihalcea. I'm an independent consultant nowadays, mostly trainer. I'm a Java champion. This is where I blog frequently. Every week I write an article on my blog. I'm also using Twitter and LinkedIn, and on my GitHub account, you can find even the examples that I included in this presentation. Now, this presentation is basically part of the research that I've been doing on my blog, and also for this book that I wrote, High Performance Java Persistence, which is also the name of this presentation as well. Okay. All right, so let's begin. As you will see, we're going to talk about various topics, and we start from mappings. We will talk about caching, about connections. As you will see, there are various tips that I'm going to show you. And now, one of the very first one is about mapping data. And even if you have, we have this standard called JPA. However, not everything that you will find there is automatically it's great to use. So there are also features there, even in the standard, and that applies to any framework, that applies to any technology, that you are better off avoiding such features. And one of those is this generation type table. Now, what it means. For instance, in order to use it, you will have to use this generated value annotation. So basically, this strategy is to assign entity identifiers automatically, because normally you could, for an entity identifier, you could either manually assign it if you know it beforehand, or you can let the database or Hibernate generate it for you. And those are the automatic generators. And one of those is this table generator. Now, why it's not useful, we will see. First of all, for this type of entity, if we have this entity, what we will have? Okay, so besides the post, having the post entity, that entity is going to be mapped on a post table. But besides that, because we are using this table identifier generator, we're going to have an extra table called Hibernate sequences, where Hibernate is going to hold the sequence values for all the entities that are going to use this table generator. Now, by default, if you don't declare a specific sequence name for each particular entity, it's going to use this default one. So far, so good. It doesn't look like it's suspicious. But then, if you take a look on the implementation, you will see a very interesting thing. Right, every time you want to assign a new identifier, that cannot happen in the same context, in the same transaction that you have. Because, for instance, this table generator basically tries to emulate a database sequence. And a database sequence, just like identity, you might have noticed that those database sequences are assigned outside the context of your transaction. That's not a bug, it's a feature, actually. So what can happen? If you remember from sequences, you could have sequence values for your identifiers like 1, 2, 3, and then 4 is missing, and then you have 5, 6. Why 4 might be missing? Because one transaction rolled back and that value was lost. Now, if that was non-transactional, anyone who would assign a value would acquire a lock, and everyone else who would want to increase or generate another sequence value will have to wait until the first transaction who acquired the lock decides to commit a rollback. That would create a huge bottleneck in the database, and that's why sequences, identity, and of course table have to be generated outside the context of your transaction. However, we are trying to emulate it. We don't have, we cannot do it internally in the database, so we have to emulate it externally. So in order to do that, what does Hibernate and JPA try to do? They try to generate that sequence value, that emulated sequence value, using a new transaction. So you have your own transaction, the main one. So now you branch from it, you create a new one, but normally that doesn't happen by suspending your transaction. It happens by creating a new connection. So right from the start, you can envision even if you think about it, you have a limited connection pool. So you increase the traffic, you artificially increase the contention on your connection pool. So right from the start, this implementation or this design looks fishy. So for instance, let's say that we are generating some, we're generating here some entity identifier, some post that have some title. For instance, for the first one, what happens when we're calling persist? Normally, we just generate we just generate the entity identifiers. In this case, you have to make sure in that separate connection, that separate transaction, you will have to make sure that you lock the record, because each sequence will have only one record in that table. So you lock it and then you update it. So, and you have to commit that transaction so that others can also generate sequence values after you. So you do that with the first, with the second, with the third. So every time you have to generate a sequence, you will have to get a new connection, start a new transaction, do that select that acquires a lock, do that update, commit, and close that connection. So it's a lot an overhead. So it's not just that you're generating the insert, you are doing so much extra work there. And even if you don't measure it, for sure that, you know, every time you're doing something and it's an overhead, that can add up. So that can affect the performance of your application. But luckily you can easily check it out yourself. So you can have, this is basically MySQL here, where you have identity and you can have table. And we're basically doing the same thing. We can use several threads. We have multiple threads trying to compete to generate the sequence values. And as you can see, identity scales way better than the table generator. The more threads you have, the more contention you have, the more time it will take to generate a sequence value, because basically you're going to wait. You're going to wait for others to acquire that lock, to update, to commit a transaction. And basically this problem is amplified the more the less connections you have in your connection pool, the more you're going to amplify this. So this is not, it looks good in theory, but in practice, it's not a good idea to use it. Let's see some questions. Is there much of performance benefit to using ordinal enum? Well, to use ordinal enum, well, yes, it could be. It could be. We know related to that, although it's not related to what we discussed, but it's a good question. So basically, when you're using enums, enumerations, you can use ordinal or you can use string. Now, why would ordinal be better? It's because it takes less space. If you're using MySQL, you can use a tiny int. That's 1 byte. If you're using a varchar, it's going to take more. So in that particular case, yes, it is. Now, the performance is going to be relative to the size of your table. If you have a table that has 1 billion records, then saving even 5 bytes, that's 5 billion bytes that you're going to save there. So basically, it really depends on the size of your database in that case. Now on the chat, let's see if we have questions there as well. I don't think. So basically, you have 2 ways. Either you can use the question and answer. There's this feature that you have there, or you can, some people, I noticed from the previous presentation that use the chat instead. So what we discussed here, this was MySQL, identity versus table generator. So basically, there's not really a choice here. Basically, it's much better to use identity instead of using one identifier, which was basically, it was designed to be portable. We will get to that as well, but it doesn't really perform well. And it's not like on other databases is any different. Like for instance, in Postgres, if you compare it to sequence, of course the sequence is going to perform way better because table tries to emulate what sequence does very efficiently internally. So of course, using all those separate connections, separate transactions that basically are going to be written to the redo log and are going to be executed on every single replica node that you have. So you are basically pushing all this overhead to other replica nodes as well. So yes, it doesn't really perform very well. That's why you are better off avoiding it. That's why, but why it's important, why I started with this is because sometimes it's just just one annotation there that doesn't tell you anything, but when you analyze it, when you put it to test, when you try to see how it works, you realize, and you realize that it's not worth using it, and you should avoid it. That's why it's better to always question any feature that you have, so that in the end you can decide for yourself which are the ones you should use and which are the ones you should avoid. This is not just Hibernate, it applies to anything, to any technology that you will eventually use. All right. So that's the table generator, but now comes the question here. What happens? Normally we don't use this table generator directly. I don't think, I'm not sure if I've seen it directly, but however, I've seen it used indirectly. For instance, for many, in many applications, this is very typical. Either people use this generation type auto, which is automatic, or basically you can just avoid, even omit the strategy altogether, because this is basically the default. So if you just use generated value, that you are going to use this auto. So why is this any way irrelevant, what we have discussed so far? And in reality it is, because prior to Hibernate 5, I don't know if you use Hibernate 3 or 4, you might remember that before, when you use auto, it was mapped to a generator that was called native, which was favoring identity. If identity was not supported, like it was the case on very old Postgres or very old Oracle databases, like how they were 20 years ago, then it would fall back to sequence. But after Hibernate 5 was released, this strategy was changed. So now auto basically is mapped to the sequence style generator. And the sequence style generator checks the database. It basically looks at the dialect. And if the dialect tells it that the underlying database doesn't support sequences, nowadays many databases support sequences. Oracle has it, Postgres SQL Server, I think it has it since 2012 or something like that. And MariaDB has it since 10.3. It's just MySQL that doesn't have it. MySQL 6, MySQL 8 introduced a lot of feature. It's actually miles away from what MySQL 5.5 or MySQL 5.6 was before. It has many features. Unfortunately, it doesn't have sequences. And for MySQL, it's going to fall back to using table. So it's going to fall back to using. So if you're using auto and you're using MySQL, you're basically using the table generator, which we saw that it's not useful. However, the thing is that for MySQL, you are better if using identity, because for MySQL you don't have a lot of choice. But the goal of this table generator was to make it portable. That's why it was created. It was a single identifier generator that could work on every database. Unfortunately, it works very slowly on every databases. So if you think that you don't have any solution, in case you have to support portability. Now, normally you don't need portability because many projects are just designed for a single database. For instance, if you're at the bank, maybe you're using Oracle, or maybe you're using SQL Server. So you don't really care about portability because it's not like you're switching your project from one database to the other every year. I actually, in 17 years of my career, I only did that twice. But maybe you're developing some frameworks or some products that you want to sell to customers, and the customers can have any database they want. In that case, there's still a better way to achieve portability than use the table generator. And that way is you can do it like that. You can still use sequence by default, which is going to work nicely on Oracle, Postgres, SQL Server, MariaDB. And just for MySQL, you can do this trick. You can still use sequence, but just for MySQL, you can provide some ORM XML files that basically just override the identifiers, because XML mappings can override the annotations once. So basically, if you do that and you supply these XML mappings just for MySQL, but not and ignore them for every other during the build process, of course, ignore for all the other databases, then you can achieve portability in a much more performant way. I see there are some questions here. Is there any specific use case for table? No, I don't think. It was basically started as a good idea, but the implementation is not really worth it. Let's see, will it affect the performance application if we use UID? Yes, of course. Using UID, especially for MySQL, is a terrible idea. This is like the table generator. It looks very nicely in theory, but in practice it's a terrible idea. Don't use it, because in MySQL, every table is a clustered index, and clustered indexes are balanced trees. Basically, a table is a balanced tree, and balanced tree, of course, are ordered and sorted. And that's why for MySQL and SQL Server, it's nice to use an auto-incremented number, because then the fill factor of every page is going to be optimal, and you're not going to split pages unnecessarily, and every new record is going to just be simply appended towards the latest page. So that's why it's not, especially for MySQL, it's not a good idea. Not to mention that it takes a lot of space, and that amplifies with every foreign key that you have. Looking at the diagram, sequence is more performant than sequence. I'm not sure. Sequence is more performant than table. Why is Hibernate using sequence as auto? Because sequence is basically the sequence is very useful, because you can, as you will see, you can automatically batch JDBC inserts, which you cannot do it with identity. All right, so those are the questions. Now let's some questions. I'll try to answer as many as possible. Now, another thing also related to mapping is about custom types. Hibernate has a lot of types, basic types, which are very useful. Most of the time you can just use the Hibernate types for varchar, for numbers, date, time, timestamp. You have a lot of basic types you can use, but that doesn't mean that you are bound only to what you've been offered by the Hibernate team. For instance, let's say that I want to have some event entity on an event database table that has to store these IP addresses, because the events were generated in a network, and I want to know or to capture the IP address where they were generated. And what options we have? You can use a varchar. That's the most that's the option that takes the most space. It can take between 9 and 18 bytes. You can use a big integer, which is basically a long, and then it has 4 bytes. So there, basically, we store the 4 bytes of the network address, and then shift to the left and use 1 extra byte for the subnet mask. Or we can use something specific. For instance, Postgres. Unlike other databases, Postgres has a lot of custom types, and one of those is this INET type, which takes 7 bytes, so it's more compact than if we were using varchar. But it's not just that it's more compact, it's more powerful, because you can write queries like this one. So for instance, you can write a query, and that query can tell you can tell the database, give me all the events that were generated in this particular network. This is a class C network address that encompasses there all the addresses that were generated in this network, .1, .2, .3 until .255. So you can match all the events generated in this particular private network, like this one, for instance. And you can do that using a very simple query. For instance, if that was varchar, or if that was a big integer, that would be extremely complicated to do it. But how can you do that? For instance, you can use custom types for that. Now, not only writing your own custom type is not really that difficult, but if you don't have to do it, that would be even better. And for that, I have this project, the Hibernate types project, which has modules for Hibernate 6, actually for every Hibernate version from 4 to 5 to 6. So you can find a module that is compatible to the version of Hibernate that you're using, from Hibernate 4 to Hibernate 6. And not only that, you can have it for IP addresses, you can also have it for JSON. And you can have it for JSON using this JSON type. And that one works for Oracle, SQL Server, Postgres, MySQL, for H2, for all these databases, it works. And so not only that it works with the type, with the specific type that you have in the database, because for instance, in Postgres, you have JSONB, in MySQL, you have JSON, in other databases, like for instance, in SQL Server, you map it on an nvarchar column. But also on the database side, you have the flexibility. You can use there a DTO, you can use there a map, you can use JSON node, you can even map it to a string, and it works. And of course, why have to write it manually yourself when you can use it from a framework? Let's see what other questions we have. Is it possible to use a function or procedure that generates an ID? Well, basically, that would be no advantage over to using a sequence. It's basically almost the same thing. From a migration from MongoDB to Postgres, what a problem might have in identity sequences. If you're moving from MongoDB to Postgres, and you probably if you used UIDs, now that's a very complex question, because MongoDB has unstructured data and you have to move to a structured. Postgres has a relational table model. So during that mapping, probably you would want to assign the sequence ID, because you still have to break all that JSON. Otherwise, you are just going to dump MongoDB in a JSON column, but then you're not going to benefit from Postgres in the same way. All right, going back to the next part. So for this one, you're not really bound to using, like in this case, you don't have to use a string to map it as a string. You can have it on the entity as a string, but in the database is going to be a real JSON column. So for instance, you might, now most of the time, you would still want to use the relational database structures, but for specific use cases where you want the raw data, a raw JSON data, you don't have to add a MongoDB just to store JSON. You can have it nowadays in a table or in a separate table if you want, in a relational database, because most of them now support JSON. And for instance, not only they support JSON, but you can take that JSON, you can take the JSON structure, and using all these databases offer you the possibility of transforming JSON data using queries to transform it to relational data, so that you can further transform it using SQL. So you can dynamically transform data from JSON to relational data using queries, which is much more powerful than, for instance, what you have in MongoDB, or at least the query from a query perspective. So this is much more powerful. And that, for instance, in Postgres is done using a cross join lateral, using this function, which basically takes the JSON object and transforms it. It's for arrays. It parses and maps them dynamically to a table that you define. You define the structure here. So it's, I would say it's quite powerful. All right, the next thing, which is also not, it's most of the time it's overlooked. It's about statement caching. Now, few people get to think about it, because this one has to be configured on the JDBC driver level. Now, most developers, when they think about JDBC, they automatically think about the JDBC API, prepare statement connection. Oh, it looks awful. So they try to avoid it. But actually, there's more to JDBC. JDBC also has features, because all those interfaces are implemented. And in the end, if you're using Juke, if you're using Hibernate, if you're using Query DSL, all of them use behind the scenes JDBC. And you can configure it independent of all those frameworks. You can configure JDBC to benefit from statement caching. Why would you care about that? It's because it makes sense once you get to understand how statements are being executed. From the application perspective, you have the statement is just a string. You send it to the database where it's parsed, and then the string is going to be represented. You have an abstract syntax tree that was parsed based on the SQL grammar of that specific database. And that only tells, that query or abstract syntax tree only tells the database what you want to get from that statement. Now the database uses it has this optimizer that generates the most efficient plan to give you to execute that statement. And of course, once you have the plan, you can execute it and you get the result back. But all this process, parsing, generating the plan, takes time. And some databases have this execution plan cache, like SQL Server, DB2, Oracle have this cache. You can benefit from it. That's why it's useful. It's useful because once you understand it, you can even write queries that can take this into consideration, and then that can be efficient and generate in such a way that they can benefit from this execution plan cache. For instance, if you're using Oracle, you can use this execution plan cache. The same with SQL Server. And on these database, like for instance in Oracle, you can even have different, for the same query, you can have different plans stored and cached for different bind parameter values, in case those bind parameter values don't have the same selectivity. Maybe one, like in case of enums, maybe one is highly selective, while other values are not. So you can have multiple plans. In Oracle, that's in Oracle. In SQL Server is not as complex, but at least still you can still cache one plan per statement. Or even if you don't like the plan and other plan was generated before and was better, you can go to the query store and pin the other plan. So you have some flexibility. Now, Postgres, MySQL, these open source databases, they are not, you know, for some people, they always consider that they only take a look at the SQL, well, how you can write a query, but basically how you can write a query only tells the database what you want. It's just how expressive it is. The implementation, it's like an interface. The implementation is different. Now, some people question whether Postgres or MySQL are as powerful or as powerful or feature-rich as Oracle or SQL Server. Of course, they are not. For instance, if you invest billions of dollars for 40 years into a product, of course, it's going to show. It's going to have some advantages. So Postgres, MySQL are great, really great databases. For most projects are great, but still, they are not. You don't have all the features that you have on the other databases. The execution plan cache is one such example. And how it works in Postgres, because this is nowadays is very popular, so it's good to know it. You don't have this execution plan cache, and basically for the first five statement, why 5? Because you have this threshold value. It's the prepare threshold property value for the first 5 prepare statements that you execute. So you have one prepare statement and you execute it 5 times for that connection. And every time you execute it, a different plan is generated. On the 5th execution, is going to generate a generic plan and is going to use that plan only for the duration of that particular session that you have, until basically you are going to call release that particular connection. So that's how it works in Postgres. In MySQL, it's like this. You don't have an execution plan cache. Prepare statements are also emulated, so you are not really calling prepare, getting a handler, and then execute it afterwards. You just go in, just like with plain statements, you go in one with a single database round trip, unless you're using this server-side prepare statement. And using cache prepare statements, you can cache the statements on the client side. So that's what you have on the server side. You also have the option of caching things on the client side. As I told you, JDBC has these interfaces, which are implemented, of course, by actual objects that you are defined by the driver. And basically the statement cache can use the metadata of the statements inside those implementations. So in order to use them, most of the time they are not enabled. For instance, in Oracle, you have to explicitly enable it, like using this with this property. You have to dictate the cache size. Once you set this property, you have a client-side statement cache, and you can even disable it for certain statements. You also have in Oracle an explicit client-side statement cache, but not only that, it's much more difficult to use it. It's also more dangerous because it can also cache execution state and data, and that's not really great, because it can reuse things that it shouldn't from one execution to the other. But also that's not it's also very hard to use, because you have to use this specific API, make it impossible to use with the framework that you most likely are going to use anyway. In SQL Server, you also have this statement cache, which has to be set by setting two properties. One is to disable the disable property. So you have this, you have to set to false the disable statement, which is a very terrible way of choosing configuration properties. Every time you need to configure something, call them always enable, so that you enable it with true, you disable with false. But that's just one a tip about designing APIs. But basically you have to enable it, and then you have to set the cache size, and then you have this statement cache. This is for the Microsoft JDBC driver, which nowadays is open source, and it's a great choice. It was not always like that, but nowadays this is the best choice for SQL Server. In Postgres, it's enabled by default. You can only vary the cache size of the statements and the length or the size of the cache. And in MySQL, you can enable it. It's disabled. You can enable it explicitly. And if you do it, you can also set the cache size, because the default value is quite low, and the SQL and the limit of the statement, the maximum limit of the statements, that otherwise those statements would be ignored and not stored in the cache. So that's what you have for the statement cache size. Most of the time, these I rarely get to see those set properly, and it's basically a pity, because for many databases, once you enable it, you can get better throughput with no code change. It's just basically just configuration, because statements are usually executed quite a lot frequently. You can really benefit. And if you, especially because we're using connection pooling, and when you do a close, you're not really closing the connection. You're closing the statement, but connections are not really closed. In reality, connections are only released. We say that they are released to the pool, but they are still open and they're deallocated from your thread. So that's why it's really useful to enable it. All right, before I'm jumping to the next part, let's try to see some more questions we have here. XML mapping file, how should be packed within the app? It's very easy. It's for the ORM XML file. You have Maven, you build a package, it has to go into that meta-inf folder, which normally you have it in Maven, in sources, main, resources. So you have that meta-inf, you just put it there, and it's going to be picked automatically by Hibernate. Do you have any experience with R2DBC? That's for reactive, the reactive database driver, which is, of course, an alternative to JDBC. JDBC is blocking. This one, the R2DBC, is basically reactive. And why is this useful? I don't have any experience with it, but I can tell you what's the goal for it. The thing with the reactive, when you're using reactive programming, basically it's like when you're using, how is that called? It's like when you're using those free open source licenses, that required you GPL, that required everything to be GPL. That's the same with reactive. When you're using reactive, everything has to be reactive from the beginning to the end, because otherwise, if you have something that's blocking, it's not going to work. So that's why you need. So that reactive R2DBC is if you really want your application to be reactive, most of the time, you are not going to really need it. Of course, there are applications where reactive makes a lot of sense, and many applications, the vast majority of it, can just live without it. All the internet that we've been building over 25 years is not really using reactive programming. How we're scaling? We're just scaling horizontally. We're using database replication. We're using auto scaling, and it works even with that limited number of threads. Because it works because we're just spanning more machines. Now, why is reactive useful? It's useful for consuming infinite streams of data, or for instance, if your blocking is not really on the IO, or basically, no, actually, yes, the blocking is on the IO, not on the CPU side. If you have some CPU bound load, not even reactive is going to help you there. So it really depends from one use case to the other. Could you tell us what was DBA? No, of course I cannot tell you that. That's impossible. You know, you cannot compare databases and post a comparison, because you have that David clause. You really have to, when you're using a commercial database, I really advise you to read the terms and conditions. You have the David clause there, and it's forbidden by most databases to publish comparison. That's why I cannot do it myself as well. I can tell you that some of those were open source, others were commercial, but it really doesn't matter, because you draw the wrong conclusion. The best conclusion is to see that on different databases, you just exhibit the same thing. You enable something and you get a benefit if you do that. That's what you, absolute numbers don't really matter. What it matters is to see that there is a reason why you want to do that. And that's why I mention it, because you are better off focusing on that. All right, going back to queries, there are things you can do also for queries. For instance, I can give you one example. This is a very typical way of writing a criteria query. Now, most of the time people don't write criteria queries for a very good reason, because they are awful to read. I don't like it. I use Java Persistence instead. But just for the sake of showing you something interesting here, this is how most people are writing such queries. They write, for instance, whenever they have a predicate, they just get a property from the entity. And of course, here I'm using this value, but it doesn't really matter. That value could have come from a variable that I passed. Maybe it was sent from the front end. But basically, when you do that, you're going to see this bind parameter value, which is great. But normally, this is what Hibernate does. This is not the typical way meant by the standard. In the standard, you have some parameter expression you were supposed to use, which I've never seen it in my life, anyone using it. But that was the typical way to use bind parameter values. Why I'm mentioning it is because if that value is a number, you are going to see the number inlined. That one is not going to use bind parameter values. So you might ask yourself, why does it matter? It really matters, because if you change this value, the query changes. If the query changes, it changes the hash. So the statement caching, the execution plan cache I mentioned earlier, are not going to be useful. They are going to generate, every time you change the query, you are going to generate a cache miss. So you are not going to benefit from your statement cache. So what you can do in that case, this is where you, especially for Oracle, for SQL Server, you are going to lose the benefits that otherwise you could have used from the execution plan cache on the server and also on the client side. So what you can do, luckily, there is this property which you can enable, which allows you to force criteria API to always use bind parameter values, even for numeric values. So you can use that one. And the same for the in queries. Now, nowadays it's so easy to write an in query. You can use JPA Hibernate, you can use Spring Data JPA. So it's very easy. You have this named parameter and you just pass a list and it works. But behind the scenes, the thing is that behind the scenes, that's not how it works. Behind the scenes, if you check the SQL queries, it's going to look like this. So for instance, if you have 3 parameters, you need 3 placeholders. If you have 4, you need 4 placeholders. But that means that you're executing different queries with different hashes. And those are going to do a cache miss on the statement cache on the execution plan. So even if you have the same query, but you have more or less the number, you vary the bind parameter values, you get cache misses after cache misses, and that's not good. So what you can do, you can use this in-clause parameter padding, enable it explicitly, in your application properties. And now Hibernate is going to use the highest power of 2 for this particular, for 3 it's 4, and it's going to just repeat the last value. So that means that for 3 and 4, you are reusing the same statement. For 5, 6, 7, 8, you are going to reuse the same statement. So basically, you are going to get less cache misses, and you are increasing your likelihood of using the statement cache. This is a feature that I implemented when I was working for Red Hat on Hibernate. That I implemented, I basically inspired myself from Juke. Let's see some question. Here, is procedures database better performance than SQL? For every such question, the answer is always it depends. It really depends. It depends what you're trying to do. If you're trying to process large volumes of data in the database, then yes. If your HQL is just for selecting entities that you plan on modifying, in which case, of course, it makes sense to use it. It doesn't make sense to use it for read-only data. So it really depends on your use case. Can you mention a few words about database proxies like PG Bouncer and impact of example on caching or other? I would really want to do that, but unfortunately, we would not have the time to do it because we deviate a lot from basically what we're discussing here. They're great. You can use PG Bouncer, you can use Proxy SQL for database, if you're using database replication, so that you can use routing for read-write transactions on the primary node and the read-only transactions on the replica nodes. That's one use case. The other use case is that if your primary node is down and you have automatic failover, your connections to the DB bouncer are going to be automatically routed to the new primary. Those are the use cases. Now, there are many specific things in between, but basically this is where and why you'd want to use it. All right. So that's another optimization. Another one which I bet that few of you have ever said or even acknowledged is the Hibernate query plan cache, internal query plan cache. Just like the database can have a query plan cache, Hibernate also has a query plan cache. Why? Why would you ask yourself, why would Hibernate use a query plan cache? If you think about it, JPQL, HQL, what are those? Are strings. That's what they are. They're just strings that express your query. But from a string that uses entities, entity properties, and features that are not even available in SQL, like join fetch. There's no fetch in SQL. That one has to be translated to doing the right join and the right projection. So as you can see, what Hibernate does, it does exactly what the database does with strings. It has a grammar and it parses it using the grammar and it gets an abstract syntax tree. It does that for JPQL, and of course it has to do it for Criteria API. Prior to Hibernate 6, Criteria API generated JPQL, which was parsed, and you got your SQL query that to be executed at the end. From Hibernate 6, Criteria API and JPQL, they generate a canonical model that is parsed to SQL. So why it matters? It matters because just like on the database side, parsing something takes time. And for that, Hibernate has a cache. And the default value is 2000 entries you have there in that cache. What it means? It means that you can execute 2000 JPQL and criteria queries. And if you have more combinations of those, especially for Criteria API, which generates different queries, in that case, you can get cache misses. Basically, the balance here is between memory and performance. But basically, we have memory. I mean, 2000 entries is not really that much. You can increase that value. But normally you can use the Hibernate statistics to determine whether you have a lot of cache misses. So in this case, this is the difference between a cache miss and a cache hit. It takes 5 microseconds to get it from the cache, or 315 microseconds to parse it. You say, but 315 microseconds is brilliantly fast. It is, but you have to do it 5 times for every transaction that you're doing. Why waste more milliseconds than you should, when you could just, and the more you're doing, because if you do this in parallel, And because you're doing a lot of statements per day, why not just save all that extra processing to do other things which are more important using that cache. So you can enable it using these properties. So that's another thing. It also has one for native SQL queries, which is just for the binding, for the bind parameter values. All right, let's see some questions. A link to download the presentation. I can give it, the link is going to be available. I'm going to give it to the organizers and they will distribute it for you. Criteria builder with predicates will impact performance more? No, it always, when it comes to performance, it's based on the SQL. That's it. You do the explain, analyze, that's where the performance comes from. How would you test these optimization in code? I mean, not real system. I don't really understand that question. How to manage transaction in microservice architecture? Great question for an 8-hour workshop. Basically, it's very complex to answer it. What you have to do, it really depends. Microservice architecture, are you using the same database, multiple databases? Are they distributed? Are they sharded? Are you using a distributed database like Yugabyte? There are so many questions and the answer varies depending on what you have there. You have any suggestion how to pass Oracle 1000 limits? You don't need that. You don't need to pass more than 1000 limits. Think about it, what a query, if you really think you need it, think about why you need to have it. Because most of the time, if you're using batch processing task, just as the name it says, you have a batch. So you need to operate on smaller batches. If you're using an application where the user tries to do that, why would they want to know exactly what are those 1000? Because normally you cannot even focus on more than 20, 50 things at the time. So that's a code smell for me. Most of the time, you can basically replace it in your case using a subquery. Use a subquery instead. And you can replace it with that. And you do just a semi-join, like with an in, and then you have a query or an exist query. All right, I'm going to try to answer other questions as well, but let's try to move on to other things we have. This thing, another great thing that you have and few people get to think about it. In JPQL, distinct has two meanings. One meaning for scalar queries is to basically push this thing from JPQL to SQL. For instance, I have a list, I have a post table, and every post was published on a specific date. And I just want to know what are the years in which I published, maybe I'm not a frequent blogger, what are the years in which I published articles. For that, I can use distinct, because I don't want to have duplicate entries. If I published 50 articles in a year, I don't want that year to be repeated on and on and on. I want distinct. So in this case, it's very good to use this. It makes sense to use this distinct to push it from this JPQL to push it to the SQL query. That's one use case. The other use case, which is probably even more frequent, is this one. You're selecting parents, but you're using join fetch to also fetch children. So you have the parent has a collection of children, and you want to get all of them. You want to get the entire hierarchy. So what you're going to do. Now, there is a very dumb thing that Hibernate and JPA does by default. I don't know why it was in Hibernate, and I don't know why it was standardized in JPA. I mean, who wants to get duplicated object references of the parents every time you have a child? You know, when you're writing the join between a parent and a child, of course, the parent record is repeated for every child, because everything in SQL is a table. You don't have like JSON with hierarchical structures. So it has to be included like in a table, like in Excel. But once you get it in the application, you don't really need to have duplicate object reference that point to the same object on the heap. So those should have been deduplicated automatically, but they were not until Hibernate 6. Hibernate 6 fixed that. But until you're moving to Hibernate 6, which is probably going to happen from 2023 onwards until you migrate to Spring 6 as well. Until then, what happens? You write this query and distinct is going to be pushed to the SQL query. Now, normally you think, and so what if it's pushed to the SQL query? It doesn't really affect the outcome. Yes, it doesn't really affect the outcome because all the results here would have been unique, because you see you have this post comment ID, which is unique. Every comment has its own ID. So yes, distinct doesn't influence in this case the correctness of the results, but it affects the performance, because if you take a look at the execution plan, you see some extra steps that are not needed. An extra sort, there was no sort here. You see an extra sort and some unique process there running at the end because of the distinct. So it's just like you're doing extra steps that you didn't need. For that reason, I created this hint. The pass distinct through, and you set it to false. And if you do that, you are going to get the deduplication of object references in Java, but you are not going to push distinct in SQL. And for that reason, you are going to get rid of those extra steps. So as you can see, there are all sorts of optimizations that have been added into Hibernate, which that's why it makes a lot of sense to check the release notes from time to time and also to read the documentation, because otherwise it's very hard to keep track of all these extra features that are developed. All right, let's see some more questions. Hibernate, are logs affecting Hibernate performance? Well, normally Hibernate logs affect performance just like any other framework logs. Of course, if you generate lots of them, it's going to affect performance. That's why you can use the log configuration to decide the level of each particular class package. Normally, you don't want to log more because it will really affect performance. It's true. But you can you have the flexibility of deciding between them. Have you ever found a single case for eager? No. Actually, that's a very good question. For fetch type eager, which is the default for many-to-one and one-to-one, it's very unfortunate. It's very unfortunate because JPA is basically a standard, and features are voted democratically. And I ask my colleagues at Red Hat, who were basically in that meeting when they voted for that default eager for many-to-one, one-to-one, Hibernate voted against, but they were overruled by other votes. So that's why we have it now. No, there was no good use case for them. Only very good opportunities for consultants to fix the issues related to that. What are the main advantages of Hibernate 5, Hibernate 6? Just briefly, better performance because of the way parameters are going to be read from the result set, the canonical model that provides you with lateral join, with window functions, with the way that blade persistence works is going to be integrated into Hibernate 6, better type systems. So yes, it's going to be really useful. Can you explain the difference between Hibernate Reactive and JPA? Yes, of course. Hibernate Reactive is if you need reactive programming. JPA is if you don't need reactive programming or reactive model. That's basically the only difference. Are you developing an application that from the beginning to the end has to be reactive? Use Hibernate Reactive and R2DBC or Vertex drivers. Otherwise, use Spring Boot with JPA, with JDBC, and a database. I would say that most of the time you'll use the standard way. If you use JPA specification, will cause cache misses like criteria query. It could be the one from the Spring Data JPA. I haven't checked it, but it's a good question, and you might want to investigate it. All right, let's see some more things. Another thing which is very useful and most of the time is overlooked is basically related to the persistence context. In JPA and Hibernate, you have this persistence context. When you're executing a JDBC, you're executing a statement, you have JDBC, and you get the result set. From that result set, you get an object array for every column based on the position you have it in your projection. And that object array is used to hydrate. You basically you call this process hydration, and you get the entity. Now that object array is also stored. It's also stored in the persistence context for the dirty checking mechanism to determine whether you changed or not a given entity. And that's the same one which is stored in the second level cache. Why I mention that? Because it really matters to know that when you have a read-write transaction, you are storing that extra array, and at the end during flush, you are checking property by property to see if you have modifications. And that takes quite a lot of time. That's why if you know right from the start that you don't need to modify entities, you can use in Hibernate, you can set the session to be read-only or on a per query basis. But most of the time, you're using Spring. So you can just use and declare the service method level that you have a read-only transaction, in which case you just discard that load state right from the start. So those entities are not going to be checked by the flush. The flush is going to ignore all those entities. That's a very easy optimization you could do. Now, another thing related to fetch is about pagination. What's nice about this pagination API is that this one works not only for JPQL and criteria, it also works for native SQL queries. And you can reduce the size of your state. Most of the time, you don't really need to fetch a lot of data. A lot of performance problems come from fetching more data than you really need. So it really makes a lot of sense, a lot of difference between fetching 100,000 records and only 100 records. It really, it takes way less time. And not only that it takes way less time, but basically it doesn't really matter whether your table grows from 10K to 100 million. If you select and you limit to 100 records and you're using an index, it's going to be fast. Otherwise, if you're using those find all methods and use streams, Java streams to filter them in Java, that's not going to, it's going to be slow. The more data you have, the slower it gets. So you should avoid that. And why I'm mentioning it? Because in JPA 2.2, you also have support for streams, which is nothing new because basically Hibernate already had this basically via scroll previously. Why I'm also mentioning it is because you really have to understand how the driver works. If you're using MySQL and Postgres, it doesn't really matter that you set it to use streams because you are going to prefetch everything. The driver prefetches you everything. If that query was could find in the database 100,000 records, all of them would have been prefetched even before you start streaming the data. That's why you have to use the fetch size for that. So the problem with these streams is that if you have this query, I'm selecting and I'm ordering by the created on, I'm selecting some posts. And I'm telling that I want the fetch size I want to be set to only 50. So only 50 elements are going to be prefetched from this query execution because I want to stream over it. I'm using this get result stream. And I'm only limiting in Java to 50 elements. And I created this index. So let's see how it works. When I'm executing this, I'm basically loading, I'm basically just using Postgres auto-explain to see the underlying statement. And I checked the statement, it took 2 milliseconds to execute, and it was a sequential scan. No index was used. Why? Because the database has no idea what I'm going to do with that data. Basically, it assumes that I'm going to traverse the entire table, 50 elements by 50 elements by 50, but in the end, I'm going to stream it all. It doesn't know about this. That's why it ignores my index and it chooses a sequential scan. Otherwise, if you're telling the database that you're interested only in 50 elements, you can do that using pagination. In that case, the database knows that it's going to fetch only 50 records and is going to switch to an index scan. Always tell the database what are your intentions. If you do that, you can get better performance. Other things, you should avoid the open session in view. This one, unfortunately, is enabled by default in Spring Boot. Why it's an anti-pattern is because it keeps the session open, and in your service, you are going to get a transactional context, which uses a single session. But then because you get out of that transactional context, that connection is released, and then you have an unattached session. And during the rendering phase, if you have uninitialized proxies for fetch type lazy or something like that, you are going to initialize them silently. But how? Because you no longer have a connection. You are going for each proxy to go to the pool, get a connection, execute a query, release the connection, on and on and on. So that creates a lot of overhead, and that's why it's an anti-pattern. There are other anti-patterns as well, like this enable lazy load no trans, which makes Hibernate work like Eclipse Link, where you don't have that lazy initialization exception. You don't get it in Eclipse Link, not because of some genius implementation, is because it basically simply opens a new session, a new connection every time you have an uninitialized proxy, even outside of the context of a transactional context, which basically is just a mistake because it hides a performance problem behind, and you are not going to reason about it carefully. Now, let me check. I'm not sure if for the organizer, because we basically have the time. So if they don't mind, we can continue the presentation. I'm probably going to require like 10 more minutes for that. So if the organizers are fine with this, then let's simply continue. All right, now related to batching, another thing which is most of the time overlooked. I'm not just saying it, it's on Reddit. This was an article written by IBM about 5 things you might not know about JDBC. One of them was the fact that you have JDBC batch updates. Now, this feature has been available since 1998 or something like that. So it's been available for 25 years, almost 25 years. So why is it useful? It's useful because it allows you to reduce the number of database round trips. How? You are basically using a buffer to store multiple sets of bind parameter values for your prepare statements. So instead of going one by one, you go only one time. So how we would benefit from that? We can benefit because in Hibernate, we have this thing called the entity manager, the persistence context, where even if you call persist, it doesn't mean, or even if you change something, it doesn't mean that the statement is executed automatically. You need to wait for flush to execute the synchronization between what you have in memory with what you have in the database. And that one can give you this way of working, can give you the possibility of doing some optimizations during the flush mode. Like for instance, trying to reorder statements and do batching there. So how it works? It works because during flushing, you have these action queues, which you can execute inserts, update, and deletes, and you can batch them automatically. Normally, there's no batching. So you're persisting 3 entities. You go to the log, you see 3 insert statements. You go to the network, you see 3 calls to the database, one after the other. No batching by default. However, you have a single property which you can enable, and you can get an application that was developed for the past 15 years with Hibernate, and you can transform it with a single property. You transform it from non-batching to batching, which is great because if you were using query DSL Juke, you would have to change your code. If you're using MyBait, Spring Data, JDBC, the same way. You would have to change your data access layer to switch from non-batching to batching. With Hibernate, one property, that's it. You write that in your application properties, and you now have batching. And you can even override it on a per session basis. You do that, instead of 3 statements, you only get one. One statement is executed with 3 sets of bind parameter values. Lovely. Thing is, it's not enough. If you're using Postgres, you can take a look at the network. Indeed, you see one single database round trip. But then once it reaches the database, if you log the statements, what the database does is basically just iterates over this list and execute the statements one after the other. Of course, it does it in the application memory, in that application thread. So you saved on the database part, but you can do it better. Postgres, the driver, introduced this property. That's why it's good to take a look on the release notes also for the JDBC driver you're using, because they optimize it. So you can set this property, and now before the execute call is made in JDBC, it basically changes your query, and it changes it to multi-value statement like this. So not only that you save the round trips, you also save the executions on the database side. I bet that not many of you knew about it unless you read about what they've been developing in the driver. The same, so you can see the difference. There is an optimization. Those are the best optimizations. You just set a property and it works faster. No code change. That's the best. You have it in MySQL. That's what's surprising. I didn't know about this like 4 months ago. I also discovered it myself. I thought that doesn't work for prepare statement because the documentation didn't say anything about it. So I just simply discovered it in the release note and I tested it out and it works. It really works. With one setting, the best statements inserts worked faster. That's why it's very nice to read the release notes. Other things which are also nice, the updates. You have an entity and you make some changes. You fetch one property, you fetch one entity, you change the title. Fetch another entity, you set the likes. You do the flush or is done automatically. You check the query, one query execution. Why one query execution? Because the default update includes all the properties. So that's great for statement caching, that's great for batching, but it's not good if you have large columns. If you have a lot of indexes that have to be traversed because the database thinks that you really changed the properties, even if you didn't. For replication, that's going to be done also on the replicas. So it's not always good. That's why for some entities, you need to use this dynamic update, in which case the update is generated on the fly. Of course, you are not going to benefit from statement caching and batching, but it's going to be much more flexible if you're using something like YugaByDB or on SQL Server. Another thing is for updating data. If you fetch entities and they become detached and you change them afterwards when they are detached, you can either use merge, which is basically what you take a detached entity and you merge it with what you have in the database. But this process, default process, requires you to do a lot of selects because merge requires you to fetch the latest state, copy the detached one, and let Flash decide whether it really changed it or not. But you generate so many selects. This is surprising. Not only that you generate the update, you have these selects as well. And if you have a batch processing task, you might want to avoid doing that because you know that you made those modifications. In which case, you can use this Hibernate specific update. You unwrap the entity manager to a session and you call update instead. If you do that, you get rid of the selects. So now you only have the updates. And the last thing, because we're running out of time, is about connection. This is the last thing I promised you. And this is also very important because you don't get to think about it. You're writing transactional in Spring on your service. How it works. Transactional is going to have the transaction interceptor aspect running before your service. That one is going to create an entity, manager is going to create an entity transaction, and calls begin. What it happens, Hibernate has to make sure that you disable the auto commit check, because that one is enabled by default in JDBC. The only way it can do that is to get an actual connection, and that one becomes attached to your current transaction, because one transaction can use only one connection. In order to know the auto commit check and to disable it, it has to fetch the connection eagerly. And if you do that, and in your service method, you are reading an XML document, parsing it, or even worse, calling another microservice, you are doing those processing tasks by holding the connection and depriving others from using it. And that's not good. What you want to avoid acquiring the connection eagerly. So what you can do, you can tell your connection pool, like Hikari, to disable auto commit by default. So every time you get a connection, it has auto commit disabled. And then you tell Hibernate that you did that, so that Hibernate can avoid doing this. So then it's going to acquire the connection only when it needs it, before flush or before a query. And once you do that, you can see a difference. You can see here a difference because you are going to hold the connection for a much lower time interval. And that's the last thing that I wanted you to present. Before we end this presentation, I want to know that there is a feedback form. You can scan it with your phone here available. So thank you very much.